Yo! Welcome back to the development diary of Saikyo, the cross-platform language learning app. Last time, we talked about cross-platform app architecture, and I went through the various perspectives that exist when it comes to making a cross-platform app. And we also talked about what we'll do, namely having the platform layer be the main driver of the program. And I also touched just a little bit about how currently companies that I've seen and cross-platform, open source cross-platform apps that I've seen do their cross-platform development. And we ended before we were able to talk about UI architecture. So that's going to be the main focus of today. I wanted to talk a lot about how we're going to start with the UI of the app. And if we have time, we'll actually start coding it, but we may not have time because theory heavy at the start, I think, is to be expected. But as we get deeper in, we're not going to be talking as much about theory because we're talking about it now. All right, cool. So the first thing is, let me just make a little comparison, actually. So you may have heard of, say, I don't know, Windows GDI. This is the Windows toolkit thing, widget toolkit. At least it's the old one, that's for sure. And we've talked about, I wish this would just automatically expand, but not like that. Also, we know that Apple has AppKit, and it also has, iOS has, well, there's two. There's UI Kit, and there's also SwiftUI. And then Android, I don't know why that's gone white. What's going on with this? Why is it gone white? It makes no sense. Okay, you know what? We're going to throw this away, and we're going to go hardcore and just write our stuff directly in code. Because in the end, all you really need is code. Isn't that isn't that what the LLM paper was called? It's like, attention is all you need. Well, for us, code is all you need. If I can type, is all you need. Okay, so back to what I was saying. On Windows has GDI, which is their like widget toolkit. At least it's the old one. For macOS, they have AppKit as the main toolkit. And iOS has UIKit as the main toolkit. And Android has Android Views. And Linux has, God knows, who knows what. There's like so many. There's like GDK. And then there's also, I think, is it KDE, like Plasma or something? I don't know. The Linux environment is just bananas. But there's actually another division when it comes to Apple's products. They introduced SwiftUI, and Android introduced Jetpack Compose. And Linux is still just who knows. So, historical lesson for those who don't know. Is it even a lesson? Historical information is that, and I think Windows has their own thing as well. They have like what, Xamarin? Is that what they have? Like in C#? I don't program much on Windows, so I'm not entirely sure, to be honest. But at least for the platforms that I've touched, AppKit and UIKit are so-called imperative. These are imperative GUI libraries. But SwiftUI is declarative, which is different, obviously. The word is different. And views, as you can kind of guess where this is going, were also imperative, and Jetpack Compose is declarative. And you know what? Just for the web as well, the DOM API is also 1000% declarative. HTML is by definition declarative because there is no executable code in HTML. You just say to the browser what you want to have happen, and then the browser takes care of making sure that happens. Even with JavaScript, I guess that would be maybe the difference, right? So maybe you could say that vanilla JavaScript was imperative, but things like ReactJS and Vue.js and who knows whatever other libraries there are, these are also declarative. So you might be wondering, Simon, you've thrown these words around, but I don't actually know what they mean. And the easiest way to explain it is that with AppKit and UIKit, with Views, what you do is you define the widget. For example, you might say, I have a button and that button has a text thing inside of it. And you might do something like, button.setText. And then maybe you would do something like text.setColor, blue, something like this. So the programmer, you define the widgets on the screen, you set the properties in the code, and they're set immediately. And then you might have something like text dot was clicked. If the text was clicked, do something. So what you're doing is you, the programmer, are giving commands to the widget, setting its properties, doing an action based on whether or not it was done. You're in charge of things like caching. You're in charge of things like event dispatching. You're in charge of things like making sure that the links between the GUI and the backend like data model are kept in sync and things like this. You're in control. Imperative means that imperative is another word for I command you to do X. That's what imperative is. Now, I'm not sure about this, but if I had to guess why the major tech companies' UI libraries pivoted from an imperative style to a declarative style, what I would say is that in an attempt for their own internal teams to be able to create software quicker, they just took what the web was doing and they just ran with it on their native platforms. So what that means is that in SwiftUI, in Jetpack Compose, and in the web with these declarative frameworks, you state what you want to have happen. And then the framework ensures that it happens. And for events, etc., you define callbacks. And the framework will call your code when something happens that you can then deal with, but it's not your code which is doing the checking for if something has happened. You delegate that, or rather you, delegate that to the framework. So you aren't in control of the code that you're writing. You are, well, of course you're in control, but you're not in control of the more minutia for like event checking and also setting the actual color. You aren't setting the distinct property of the text. You're saying to the framework, I want the text to have this color, and then the framework goes ahead and makes sure that that happens. And if I can quickly try and pull up maybe a Jetpack Compose sample. Actually, I do have my own personal GitHub here where I have some sample code that I once upon a time wrote. So this is going to be on Android. So this will be Jetpack Compose. Let's see, where's UI? Oh, let's do maybe overlay. Let's see if there's anything inside of here. Yes, okay, so this is a good example. So in a declarative framework, what you do is you define each of your widgets as some kind of function, and then to then start creating more things. Well, first of all, we have this like weird syntax here. What this does is telling the framework to store some memory of some state. So we we aren't in charge of the memory allocation. We're saying to the framework, do the memory allocation for this stuff. Then we say we want a widget. So this box here is a Jetpack Compose widget. We're saying we want a box to be here. We want it to fill the max size. We aren't doing it we aren't physically filling it ourselves here. And we want it to be able to respond to pointer input. And when it responds to pointer input, in this case, a tap gesture, then we want this code to run. So these are the callbacks, right? This is all declarative. We aren't in charge of checking whether or not there was a hit on the box. We just react to a hit. And the same thing here with Canvas. And the same thing here with selection handles. So this is like when will we get a pop-up? No, we won't. You know, on a phone, if you hover over something, you get like a handle. You can drag the handle and it will select stuff. So this is a declarative framework, and it looks a lot like the web. And because it's a lot like the web, again, what I think has happened is that Google internally and also Apple internally just write code, and then they have some sort of like fancy transpilation of compiler or something, which goes through and transpiles their code into the code for, say, the web. And the reason why they're able to do that is because they're essentially creating transpilable structures in their code, so that way it makes it easy to translate between the two different frameworks. So that's the difference between imperative and declarative. Now, you might be asking yourself, which is better? Declarative or imperative? And I can tell you, without a doubt, 1,000%, die on this hill, my conviction is that imperative GUIs are the king. They're the best. Declarative is a no. Declarative is wrong. And it's not because I think one style is better than the other. I base my opinion purely off of experience. Imperative GUIs, this is also sometimes called an immediate mode GUI. Immediate mode GUIs have this benefit. One is that you control, obviously, you control everything, which means there is nothing you cannot do there and then. Whereas with imperative, if the framework, with declarative, if the framework doesn't support something, you're out of luck. There's nothing you can do about it. And this happens all the time. In fact, this happens so much that on Android, it's such a hacky way to be able to use things like Google's ad views. Because Google's ad views, the view is a view. It's using their old framework. It's not supported in Jetpack Compose. So you have to use a weird compatibility layer. Whereas if it was an imperative thing, you wouldn't care. You would just like readjust your code so that way it would use the new API of the ad view. So that's number one. Number two, for imperative GUIs, layout and UI testing are done together. And the reason why this is important is because you remove the need for callbacks. There's no callbacks, which makes the control flow is easier to understand. Debug, test. So the control flow is easier to debug, easier to understand, easier to test. Whereas now, if you do it from a declarative framework, you have like callback hell for one, but also you have tons of callbacks. For example, in Jetpack Compose, there's a callback, I believe it's called like on text layout or something. Yes. There's a callback for like on text layout just to know if text layout has overflowed. And it's ridiculous. And the reason why that's important is if you had, for example, a very long sentence and it wouldn't fit in the allocated space, what people normally do is either have a dot 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 here or like a more button so that you can click it. If you have a declarative framework, you literally it is impossible while you're in the middle of writing these composables to know whether or not you need to actually cut off the end of the string, replace it with dot dot dot, or put a button here. It is impossible to know that because you don't do the layout yourself. And to get around that, indicate text overflow, right? You either have to say what you want to have happen, and again, this goes back to the first point. If the options that Jetpack Compose offers are not there, then you're out of luck. There's nothing you can do. Which actually brings us to another benefit of having the layout be done there and then, which is that you can deal with it's easier to deal with so-called lazy data structures. And the best example of that is, well, actually, if we look at our editor right now, you can see, right? We have this entire code file, which is what, 102 lines long of actual code, right? This does not completely fit inside of the view. I can guarantee, because C-Line is written using Kotlin or maybe Java, and they're going to be using, I don't think C-Line uses Jetpack Compose internally. I think they still use Swing or whatever. But I can guarantee to you that inside of their code, which is saying what to display inside of the UI, there is going to be no code which knows that this text file will not fit inside of this window until after the fact, because it's done out of line, because it's probably declarative. Although I suppose if it's Swing, it may not be done. No, it's probably still done out of line, because even in Swing, I think layout is handled by Java Swing itself and not by the programmer. So the saying what is in the UI versus laying out the UI are done in two different steps, which is ridiculous. So that's number one. The next thing of why you want imperative GUIs is because you're in control of state. And I guess this is probably an argument people make when it comes to declarative GUIs, which is that you don't have to worry about state. So I don't have a sort of technical, well, I'll say what I'm going to say. I think it's a difference of philosophy between immediate mode GUIs and declarative GUIs. The people who support and encourage these sorts of declarative GUIs usually, I mean, let's be real, they're trying to lock you into their platform. And by doing that, they give you all of these benefits, like you don't need to worry about X, you don't need to worry about Y or Z, because we'll handle it for you. Well, if you let them handle it for you, you are now tied to them. And if we go back to the goals of this app, which is that we want to have optimal performance that we can reasonably guarantee, reliability, user experience, then every time that we let somebody else deal with a responsibility we should be dealing with, we are compromising one of those goals. So we don't want to do that. And that's why an imperative mode GUI is important. We're in control of when things are allocated. We're in control of when widgets over here reference widgets over here. We're in control of where the memory for those things come from, which is another important thing. And we need this control because with great power comes great responsibility. But with this control, then we can start doing crazy things, like animations that do completely different things based on the state of the app, or canceling things in the middle of other things promptly and quickly, or even doing things like, well, there's tons of things. I can't think of every example right now, but the point is, we want this. And I suppose the last thing that I'm going to talk about when it comes to imperative mode GUIs, which is something I already kind of touched on, is that we are in control. No, we can enforce performance, reliability, experience. And the truth of the matter is that you cannot do that with a declarative framework. With performance, etc., guarantees up to the implementing framework. So this is, and I think for me, this is the biggest problem. You know, we want to have the best experience for the user because in the end, the user is the whole reason why we're doing this. So if we cannot guarantee the best of experience for the user, then we need to reevaluate what we're doing. And I just don't believe declarative frameworks offer those kinds of guarantees. So that's why what we're going to do is we're going to make an imperative GUI. Now, even though we're going to be making an imperative GUI, to be honest, the first GUI that I ever learned was Jetpack Compose. So I'm somewhat partial to its kind of like naming conventions and things like this. And the way that they let you create these sorts of composables. So we'll be taking some inspiration from Jetpack Compose during the development of our GUI. Where is it? Yes. But we'll be putting our imperative spin on it, and we will see where this goes. So I think that's all that I wanted to say about the way that GUIs need to be. What am I saying? This is all I wanted to say about GUIs, and I want to actually get to the beginnings of writing our own GUI to begin with. So I think in the remaining time, what I'm going to do is I'm going to start making our platform independent layer right now. So we'll call this one maybe saikyo.hpp, and we'll use Pragma once here. I can't remember if I've talked about Pragma once, but in C and C++, right, there's different ways to make a header file. And the standard way to do it is that you would say, if not defined, thing, hash defined, thing, and then you put your declarations inside of here. But this is like, 2 lines too many, and Pragma once achieves the exact same thing. And all of our code is going to be on a single drive. So there's no like weirdness with operating system, network drive craziness. And Pragma once is supported by every compiler that I care to use. So we're going to use Pragma once for our header. So let me just include this. Hash include saikyo.hpp. Awesome. So the first thing that I guess that we'll do is we will see how we're going to actually write the code. So I think what I'm going to do is let's just make, in our run loop here, let's see what we'll do. So we'll do maybe UI. We'll just call the UI, and we'll have to pass it something. So what are we going to pass this UI function? Well, first, what is this UI function? I suppose it'll be some sort of auto void UI. And I guess for now, we'll make it take a void star, and it will return nothing. And then maybe what we'll do is we will touch one more file. We'll call this UI dot HTTP. Hash includes you. No, hash include. Sorry, you're a Pragma once. And here we'll define the function. So order void UI takes a void star. If I could type properly, which is always a difficulty. Static UI void star, and this returns nothing. And we'll just put that there. And as part of our Unity build, then we will hash include inside of here UI.hpp. And we'll pass to null pointer for now. And does this build? It did. And it looks like left mouse up is actually deprecated, sorry. So we will use, I'm not quite sure what the point of that is. Like, does it, what's the point of just changing the naming? Like, just leave the name the same, whatever. But do we use this here? We used that inside of the square block. Oh, I get it, because this is a global variable, isn't it? Yes. Whereas this is an enum. Okay, that's fair enough. You know what, Apple? I was wrong. I do agree that using this is probably the nicer thing to do. Okay. So do you compile? Yes, you do. Very good. All right. So if I just try and write some of the code of what I'm thinking of, if I write what I want the code to start looking like, what kind of UI will we first make? Let's just make like your typical like header body footer looking thing. So the header will be just like a block of color. And the body, I don't know, just like a white body. And then the footer will be another block of color. For now. So what I would want is to be able to say something like compose maybe something. I would say compose something, and then one thing that Jetpack Compose lets you do is that it lets you use lambdas as their UI functions. Like in Jetpack Compose, every UI widget is a function. And it's when you call the function, it will quote unquote emit UI widgets into a hidden thing that the Compose runtime manages. For us, we're going to follow the principle of explicit is king. So this hidden magical thing that Jetpack Compose uses, we're going to just pass through this compose function looking thing. But I do want to use Lambda functions because Lambdas are pretty cool. So we'll do this. And we need to put down some color. So what should we call this? Maybe we'll just call this maybe layout, like this. Or compose. Let's figure out what this compose thing is going to be first. And we'll put that inside of our header. So in compose, they have a thing called the composer, which is that hidden object thing that they have in the back of their, behind the scenes, that the compose compiler. I'm talking as if people know what all of how Jetpack Compose works. I'll try to stop doing that. Basically, there's a hidden object that gets passed around in Jetpack Compose, and they call it the composer. They call it composer because it's an object, and objects have methods and blah blah blah. But we're not going to do that because our code is functional. So we're going to call this the composition instead. And so what I actually want to pass through down to the UI is this composition thing, and we'll call this the composition. Oops. So let me just change the definition here. Awesome. And this compose thing, if it's going to take a lambda function, that implies that compose itself needs to be a template. So we'll say type name function, and this will be static auto compose. And what this does is it takes in the composition. And it takes in this, what shall we call this? We'll call this widget. And this will return something, maybe? We'll have it return a void star for now. Maybe we want this to be able to return something. For example, well, actually, just passing in the widget may not be the right thing to do, right? Because we want to start adding things to the composition itself. And right now the composition is empty, which is not great. So we're going to need to put some memory inside of here so that as we drill down, we're going to start emitting widgets to the composition so that later on when we go to render, put things onto the screen, the UI, there's something to read at all. So you know what? I think we're going to focus on the composition for a little bit so we can start to figure out what will stick inside of there. But we're out of time for today, so I guess we'll do that next time on the Development Diary of Saikyo, the cross-platform language learning app. What we're going to do is we're going to start looking into what we'll put inside of the composition. And we do need to do some prep work before that, actually, because we don't have any types. We're just using int and auto everywhere, but I like using fixed width types and defining those ourselves. So we'll take a look at that next time. We'll take a look, see what goes inside the composition next time as well. So thank you so much for watching. Please leave your comments down inside of the comment section. I know this may have been a whole lot of theory again, and some of it may have been hard to ingest, especially if you're new to this. But if you have any questions, concerns, then just leave your question / comment in the comment section and I'll get to them. And we may even add them to a video. Wink, wink, smiley face. So thank you so much, and I'll catch you on the next one. Take care.